This lesson is about our trig identities. Trig identities are identities that are true for any variable for the trig functions. So the first couple we are familiar with, that tangent is equal to sine over cosine. That means that cotangent would be equal to cosine over sine. We know that our three kind of original trig functions, sine, cosine, and tangent, all have reciprocal functions. So sine's reciprocal is 1 over cosecant, cosine is 1 over secant, and tangent is 1 over cotangent. That means that cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. So those we're all familiar with at this point. Then we have our Pythagorean identities. There are 9 of them, but they all stem from the Pythagorean theorem. When we were in the unit circle, if we had an angle at our origin, we knew that we could create a 90-degree triangle, and across from that triangle would be our sine. Adjacent to that angle would be our cosine, and the hypotenuse was always 1. So we knew sine, cosine, and then 1. So using the Pythagorean theorem, we could say that sine squared, because that's the length of one side of the triangle, plus cosine squared, the other length of the triangle, is equal to 1. Squared, which is 1. So that's the first of the Pythagorean identities. If we take that identity and minus cosine from each side, we get our second identity, which is sine squared is equal to 1 minus cosine squared. If we go back to the original identity, and we, instead of subtracting cosine, we subtract sine from both sides, we get our third identity, that cosine squared x is equal to 1 minus sine squared x. So those are the first 3 Pythagorean identities. Going back to the original Pythagorean identity, if we would divide each one of these by sine x and simplify, then we would get the fourth Pythagorean identity. And the fourth Pythagorean identity, I'm trying to erase here. There we go. The fourth Pythagorean identity is that 1 plus cotan squared is equal to cosecant squared. And just like when we did our original Pythagorean identity, I could subtract each one of these terms, subtract 1 or subtract cotan, and that's where the next 2 Pythagorean identities come from. So in the second one here, we are subtracting the cotan from both sides, and then the third one, from the original, we subtracted 1 from both sides. Again, going back to the original Pythagorean identity, going back here, cosine plus sine squared is equal to 1. If we would come through and divide by cosine squared, oh, not cosine squared. Cosine squared, sorry. We would get our last set of Pythagorean identities. So here we would get, if we divided the original by cosine squared, x or theta, you would get tangent squared plus 1 is equal to secant squared. And then just like the last 2 examples, we could minus tan from both sides, get a second Pythagorean identity, and then come back and subtract 1 from both sides and get another Pythagorean identity. I'm going to show you the actual step-by-step for this Pythagorean identity and this Pythagorean identity on the back of this page. All right, so if you hop over to the back, So the first thing that I said was if you would divide by sine squared on all three, sine squared over sine squared would give us 1. Cosine squared over sine squared, cosine over sine is cotangent. And then 1 over sine squared gives us cosecant squared. So that's where that second column of Pythagorean identities comes from. If we did the same thing but with cosine squared, we have sine squared over cosine squared. That's how we get tan squared. Cosine squared over cosine squared gives us 1. And then 1 over cosine squared gives us secant. So that's the third column of your trig Pythagorean identities. So we're going to use these identities, and our goal is to just simplify down to one trig function. So there's 3 strategies in order to do this. The first one is to change any trig functions that are not sine and cosine into sine and cosine. So if you're given tangent, let's change it into sine over cosine. If you're given secant, let's change it to 1 over cosine. So kind of get everything back to sine and cosine. The second strategy is to use your Pythagorean identities. And then the third one is to multiply by the reciprocal, making sure that we multiply by 1. So let's try some examples. So in our first example, we have cosine times tan x. Well, tan x is not in sine and cosine. So the first thing that I'm going to do is I'm going to rewrite it as sine x over cosine x. Cosine x is already in sine or cosine, so we're going to let it come down. And we can see that now we have a cosine in the numerator, we have a cosine in the denominator, they will cancel out, and we're left with sine x. So we took multiple trig identities and we're trying to just get down to 1. Let me show you another example. All right, so in the second example, we have cosecant x over secant x. So the first thing that I'm going to do is I'm going to rewrite them in terms of sine and cosine. So cosecant is 1 over sine x. Secant is 1 over cosine x. And now we're going to multiply by our reciprocals. So I'm going to look at the denominator, and the reciprocal of cosine would be, 1 over cosine is cosine over 1. And I have to make sure that I multiply by 1, so I'm multiplying the numerator and the denominator by cosine x. In the denominator, you have cosine, which will cancel out with cosine. And now our numerator is leaving us with cosine x over sine x. Cosine x over sine x is equivalent to cotangent x. So I can simplify that down to cotangent x. In our third example, we have secant squared x minus 1. When I have a when I have a trig function squared and it's being added or subtracted to something else, I should think, ooh, that is one of my Pythagorean identities. So secant squared minus 1 is equal to tangent. So those two are equivalent. I'm just kind of replacing them with each other. And this is over sine squared x. So now that we have tangent, let's rewrite tangent in terms of sine and cosine. So sine squared x over cosine squared x all over sine squared x. So instead of tangent, we wrote it as sine squared over cosine squared. So we have this complex fraction here. So in the denominator, I want to get rid of that sine squared. So I'll multiply it by its reciprocal in both the top and the bottom, the numerator and the denominator. In the denominator, it's going to cancel. It also cancels out in the numerator, and we're left with 1 over cosine squared. 1 over cosine squared is secant squared x. So we took something complicated and brought it down into one trig function. This would be a good time to pause and see if you can do the bottom 3 and then restart your video and see if you got them right. All right, here we have cotan squared, so that's going to be cosine squared over sine squared times sine squared. Those sine squareds will cancel, and we're left with cosine squared. In the second example, I noticed that I have sine squared x being added or subtracted to something. So that's a really big hint that that's one of my Pythagorean identities. So sine squared x plus cosine squared is equal to 1. It's that original Pythagorean identity. And then we have 1 over secant, which is equivalent to cosine. And then the last one, we have tan x over cotan. So one thing that you could do is you could rewrite these both as sine and cosine, but I am also aware, and so are you, that cotan is equivalent to 1 over tan. If I then multiply by the reciprocal, that cancels out our complex fraction there, and then we're left with tan squared x. If you converted that all into sine and cosine, you should get the same answer as well. So those are our trig identities. They're really important as we get into solving trig functions as well.